working for startups for 18 years, and now it's my third year at ESADE as an associate professor, and I am also a director of the Master of Science in Business Analytics at ESADE in Barcelona. And basically, I am teaching machine learning at very different levels. So I have students that are undergraduates, so doing initial university studies. Then I have students from a couple of masters, the Master in Business Analytics and the Master in Innovation and Entrepreneurship. And then I am also teaching at the full-time MBA, which is maybe the most demanding program that we are offering. And then also the Executive MBA and Executive Masters, as well as some custom corporate programs. So that means that companies are interested in getting educated on machine learning. So I am also teaching at that level. So that means that I have to somehow adapt my teaching to different types of audiences. But at the end of the day, the ultimate goal is always the same, for me at least. In a business school, I think it's very important to create this kind of common understanding or common language, so that data scientists or data engineers can speak to the business people and vice versa. Because what I have experienced in my former company at the Strands, working for banks, is that large organizations have very good engineers and data scientists, however you want to call them, and then you have the business side of the activity. And at the end, these two types of professionals, they have tons of difficulties in communicating to each other, right? I think it's very important for business people to get educated in machine learning so that they can understand what type of problems they can solve with machine learning, and probably most importantly, how to translate those metrics, those evaluation methods that we have in machine learning into the business activity. Because at the end of the day, who will decide if a model is useful enough for a specific business opportunity? It has to be done on the business side and not on the data science side, right? So I am trying to educate people so that they have this understanding on machine learning, so that when they go back to the industry, so to speak, they can communicate at least with the same language to data scientists, to overcome business challenges. So the idea of this presentation is to go through 10 highlights of my teaching on machine learning for business students. Actually, it's 11. So we are going to see some of the aspects I am using for teaching machine learning to business students. And then if we have time, we can go over one typical assignment that I am proposing to my students, in which they have to basically solve a business challenge with machine learning. They have to create the model, evaluate, and the most important thing, how you map all these evaluation metrics into the business strategy or the business model, okay? So the first highlight for me would be start with the business opportunity and then think on the data and think on machine learning as a second step. Because I believe many companies, of course, they are collecting tons of interesting and relevant data for their business, and they start looking at the data, right? And if you start looking at the data without a clear business goal, you may be very easily lost in the data, because there are many, many interesting things you can discover out of the data you are collecting. However, in order to avoid this kind of, okay, let's take a look at these hundreds of things, interesting things that you can discover for your business, instead of that, I think it's much more efficient to start with the business opportunity. So first, and here is the role of the business people within a company, to identify what are the processes or the business opportunities, and then as a second step, take a look at the data and machine learning and see if machine learning can help within that business opportunity. Okay, so the first highlight would be, okay, start from the business and then jump into data or jump into machine learning. The second idea is, okay, now we have defined the business opportunity that maybe can be solved with machine learning. It's also very important to specify the action. So what would you do with that model once you have it? So before starting the project on machine learning, try to do some guesses on how you would apply that model. Because there are cases in which you may think, okay, this is an interesting model for my business because I can predict whatever thing is important for you. But then another thing is how you would actually use, how would you embed that model within your organization? And that is a different thing that is also very important. An example of that is, let's imagine you are selling through an e-commerce website. So you are the owner of an e-commerce website and you are selling items. Imagine that you can build a model that can predict the likelihood of a customer buying an item to return that item a week later. Of course, you want to minimize customers returning items, but this is a model that looks interesting, but it's very hard to embed it in your business, because what would you do, right? Once you have a customer that is about to buy something and your model predicts a high likelihood of that customer returning the item, what is the action, right? You cannot tell the customer, hey, we recommend you to not buy that product because we know that you are not going to like that product. You cannot do that because you would lose the transaction. So this is a typical case in which it looks interesting, right? Because you are investing a lot of money in these reshipping items or whatever it is the process. However, it is very difficult to imagine how you would use that model in that context. Okay, so first define the business opportunity, then specify the action, how you would embed the model within your organization. The other thing before machine learning, I think it's important also to write a mini business plan or to put specific numbers into your project so that you can know how much you can invest into that project, evaluating how much positive business impact you can get in return for that model or that project. Okay, so first, before building your model, I think it's always wise to write a business plan in which, of course, you would have to put assumptions, for example, on the performance metrics of your model, but you can assume things, right? And at least you have a range of the return on investment for that project before starting the project, right? Okay, so if we talk about writing a business plan for a machine learning project, then we need to understand for classification tasks that you have good predictions, you have wrong predictions, but of course within the wrong predictions you have different type of wrong predictions, right? This is a false positive, false negative. They always have very different costs within the business, right? So these are different trade-offs that you have to be making. Are you going to minimize false negative while false positives are increasing, or vice versa? And here again, this task, so knowing what is the right threshold or what is the business impact of these proportions between false negative and false positive is a business decision, right? So business people need to be educated in precision, recall, false negative, false positive, all these things, so that they can take the wise decisions when it comes to choose the right model for the business, right? So differentiate, the conclusion here would be, let's differentiate between the cost of a false positive and false negative, because it's always very different, and then take deciding on which model to use based on this analysis. And here I am just displaying an example. So if you are an investor and you are predicting if a startup would be succeeding or not succeeding, right? False positive would mean that the model is predicting that the startup is succeeding, but actually it will fail. So in this case, you would invest because the model is telling you to invest in that company. So the consequence or the cost of a false positive would be to lose cash, right? To lose the money you have invested. And on the other side, a false negative means that the model is predicting that the startup is not good, but actually succeeding. So you are losing an opportunity. And here, if you are a very aggressive investor, let's say a VC from Silicon Valley, you would prefer to minimize the false negative because you don't want to miss the next Facebook, so to speak. And if you are a conservative bank, probably you will try to minimize the false positive because you don't want to lose cash, right? So there is no good and bad here. It's about how you interpret these bad predictions or precision and recall, this type of trade-offs that you have when it comes to evaluating to evaluate a classification task and map those evaluation metrics within your business strategy. Again, this is a business activity, no? The data scientist or the machine learning engineers will not help you deciding on that. Then the thing is that okay, how can we influence these proportions between these different types of wrong predictions? Of course, you can go to the data, recreate the model, or fine-tune the model in different ways so that you get different proportions. But there is also this idea that you can fine-tune the operating point, so the point up to which you decide if an instance is positive or negative. By default is 50%, but you can also play with that in order to tweak the model so that you minimize or maximize false positive or false negative. And of course, what's kind of common sense, there is always some kind of interconnection between both, right? At a certain point in time, you cannot minimize the two of them, so one gets increased and the other gets decreased. The lesson 6 is about thinking how, if it makes sense in your business opportunity or the challenge that you are trying to solve, if it makes sense to transform what is apparently a regression problem into a classification problem or task. Because in many situations, you have, in a natural way, you have the prediction target as a number, and this is an example, right? Here we are predicting sales for the different products we are offering, for example, and the first temptation and the natural thing is to solve that problem as a regression task, right? But in some cases, something wise to do is to transform this numerical feature into a categorical feature, so that you are transforming your regression task into a classification task. Basically, because of two reasons. Because a classification task is usually easier for machine learning. So usually you can get better results than predicting a number. And the other reason is because the business decisions you are usually taking for your instances or for the entities that are represented behind the instances is a Boolean decision, right? In business, most of the times you have some entities that are represented through the instances, and you want to make a Boolean decision, right? You do something or you don't do that something based on the classification. So I think there is always a better mapping between a classification task and a business challenge than predicting a number, right? So that would be lesson 6. And then, well, this has been said already many times in previous presentations. It is very clear to all of us that machine learning is not just a sequence of steps that you have to achieve in order to get the perfect model, which doesn't exist, by the way. So we have this kind of experimental science, right? So there is no good or bad model. So the critical step here for me, it's the step number 4, in which you evaluate the quality of the model or how useful is the model for your specific business context, and then if it's good enough, you are done. Otherwise, you can recreate the model, fine-tuning the parameters or choosing another type of model. And if this is not enough, you can go to the data wrangling step, which we have been seeing that it's a very critical step. No, usually we are all agreeing that data preparation is the most important step, usually requiring, to say something, right, like 80% of the resources that you need for a machine learning project. Then the other important concept is that since we have this kind of experimental loop in a machine learning project, it's also important to decide when to stop this improvement process on your model. And this is again a business activity, because when you are mapping the evaluation metrics into the business impact within your organization, at some point in time, you may say, okay, the ROI that I am getting from that model is good enough, so I stop the process. Otherwise, you are also investing in this type of research or experimentation, and at the end, that could be a counter intuitive, and the ROI could end up being negative, because you are researching more, you are investing more in the research to what you would be gaining just deploying the model that you already have. Okay, then the lesson number 8, which will have different parts, is about data, because as we have said, data preparation or data wrangling is probably the most important step in a machine learning project. And here there are 2 criteria that we need to consider: relevancy and reliability. Relevancy means that the features that we are using in the model are somehow related or meaningful for the prediction we want to achieve. And here, of course, in some cases it's obvious, right? If we have the last name of the customer, this is not related to anything interesting in machine learning. But in some situations we don't know, right? And here again, it's this experimental aspect that it's important. So when we don't know if a feature is relevant or not, we let machine learning to discover that, creating the models and evaluating those models, right? So in some cases, it's not clear which features you need to select. Reliability is about if the data is correct or not. And here we know that we can somehow automate this, but we need to remove outliers. We need to have a strategy for missing values, and in some situations, for some models, it's important to normalize or standardize the data. These are things we can do, but apart from those things that are well known, I think there are other tweaks that are very important to consider when it comes to prepare the data for your problem. So the first thing would be to somehow think out of the box, because in companies, the most intuitive thing is you start looking at the data you are collecting in your IT systems, and it is very, very important try to complement the features and the data that you are getting from your IT systems with external data sources that could be very helpful in order to increase the performance of your models. And this is a very naive but illustrative example. If you are predicting sales on sunglasses for a company, of course, that company would not collect weather information, right? Because the company is not about weather, it's about selling sunglasses. So in this case, obviously, if you integrate weather indicators into your data set, you are going to increase the performance of your model. Always under the assumption that sunny days you are selling more sunglasses, which makes totally sense, right? So always think, okay, this is the data that I am collecting in my organization, but there are plenty of external data sources that you can use to complement and to enrich your original data set. And this is something that will become more and more relevant as we are having more web services and more and better ways of accessing external data. Okay, so that would be part of lesson 8. Then the other consideration also is that for large corporations like banks, of course, they have these kind of legacy systems which are very complex, which different data sources for the data. And in machine learning, we are always considering, okay, we have this nice tabular form of data. We have a table with all the features and the prediction target if it is supervised. And we have the data, and the project starts there. No? But in a large corporation, just preparing the data so that we have this nice format is a huge, huge engineering process. So we do not have to underestimate all the engineering efforts that they are required to get to the data set that we need for machine learning, right? Especially for large organizations that have been building their IT systems for the last decades. So they have databases with different providers, different programming languages, different standards of the data, and so on. So the process that in engineering we call this ETL, no? The process that collects data from heterogeneous data sources and puts all this data in a coherent and homogeneous format. This is a huge engineering process that can take years, for example, in banks, years and hundreds of millions, right? So one thing is what you can do with machine learning, but prior to that, you really need to think on how you are getting the data. Maybe you have the data, but the data is not accessible or is not available in the formats that you need to continue with machine learning. Okay, so that is kind of a consideration, no, that you need to take into account when it comes to machine learning. And then it's also known by all of us. Feature engineering is probably the last mile in increasing the quality of your model, so that's very important. And it's also the step in which the expertise, experience that you have on your domain is paying off, right? Because all the rest can be done more or less without expertise on the domain. But when it comes to create new features, which are probably a combination of the original features so that you add more predictive power to the models, here you need this domain expertise. And here again, this is something that people that comes more from the business side could play a very important role. No? So usually data scientists will not know how to do the feature engineering in a smart way. So here again, you need the business people to help you in creating those combinations or those features that will increase the performance of your models. Another thing, of course, we have this experimental process. So we are wrangling the data, creating models, evaluating the models. If we are not happy enough based on in business terms, so to speak, then we can go back to the models or go back to the data and improve the process. No? And in that way, we are improving the model. Then we are happy. We deploy the model into production. But what it always happens is that the performance of those models, once they are in production, once they are deployed in production, those performance metrics start decreasing, because the models tend to degrade over time, because of course the patterns that you had on the past are dynamically changing, because the context is dynamic. So very important to, once you deploy the model, to continuously monitor all those metrics and decide, and here again, this is a business decision, decide when all those metrics are not good enough for your business, so that you have to stop using that model and recreate the model probably with fresh data. Okay, so very important, you deploy the model and you have to continuously be measuring all these evaluation metrics, so that you decide when the model is not behaving good enough, so that you have to recreate the model, probably with new data. And remember that sentence that is also very well known by all of us: all the models are wrong, but here we are looking for models that are useful enough for our business context. And again, what is a useful model? This is a criteria or a decision that will be made by business people. And then the lesson 10 is, okay, machine learning is kind of in this hype mode. No, everyone is talking about machine learning, but at the end of the day, machine learning itself is just one little piece of all this automation that we want to achieve in a company, right? So we are using machine learning to discover new data that we don't have with the raw original data, and this new data is helping us to make decisions, automated decisions on many entities that you cannot do one by one, so to speak. But all this is just one piece of the puzzle. You need to integrate this within your organization, and not only in terms of IT or engineering, which can be very complex, right? How you integrate the model within your engineering processes or your software, that is already quite challenging, but also in terms of people, right? Who is the user of this model? Because maybe you are creating a model that is very interesting or useful for your salespeople that you have in the company, but these people have been working in a certain way for the last 20 years. So you are producing a disruption within the company, because suddenly you have all your sales team that have to change the way they have been working for 20 years. So there are implications not only from the IT point of view, but also in the way the company has been operating, probably. Okay, so machine learning, what we are here analyzing, is just one little piece of the whole scenario that needs to be considered. And then the extra session, so to speak, is that I think we tend to believe that machine learning is something kind of magic, especially for business people. No, they think it's magic, no, and you have the model, and wow, now it's perfect. We can make predictions. But very important to teach business people on the fact that this is only working. So machine learning is only working and only useful under a very large assumption. This assumption is that whatever patterns we have on the past will continue to exist in the future, right? But this is not always like that. So the context is changing, and we have seen that with the pandemic, right? So everything is changing very quickly. So those models need to be adapted accordingly, because otherwise you can be using a model that is based on patterns that no longer exist in your context. Okay, and here I have a kind of a naive example, right? If you are operating a furniture shop and you have your models, you are happy, but then IKEA comes to 200 meters from your shop. Of course, the context has changed, so all your models are not longer valid. Okay, that's one aspect that needs to be considered, in my opinion. The other thing is, okay, we rely on data, right? But in many situations and in many organizations, this data has been produced by people, right? And we know that people are not very competent usually at achieving tasks in general, and we are biased, right? We have contradictions, we don't have a rational criteria most of the times, and so on. And this is why we need machine learning, right? To take decisions in a more rational way. But then if we use data that has been produced with bias or with contradictions and so on, of course, we need to consider that that model could carry on all these biases and contradictions that we had in the kind of offline world, or in the real world, so to speak. Okay, so this is a little bit to demystify machine learning, and to say that when you apply a model into your business, you have to think about these underlying assumptions that sometimes they are kind of granted, but they are not always, it's not always the case. I would like to present you a typical assignment that we are offering to our students. And again, I am reusing this assignment for even undergraduate students, for executive MBA students. I am adapting a little bit the speech and the questions, but I think it's a very illustrative example. It's a typical example in machine learning on how you map those evaluation metrics within a business context, which again, I think this is the key point business students need to learn. So this is the problem is you are in a telco company. We are now a telco company. And by the way, the data set is from BigML Gallery. You are in a telco company. You have the features that describe the customers that you have in the company, and some of these customers are leaving the company. So we have a churn rate, which is 14%. So we have every month 14% of the customers that are leaving the company. So we want to create a model, a classification task model, in which we predict the likelihood of a customer to leave our company. Okay. So then we present some assumptions to students. So this is part of the assignment is much larger, but this is kind of a summary. Yeah? We are presenting students some assumptions on that company. We call it 5G Boost. Okay, we have 100,000 customers. The revenue per customer is $60 per month. As I said, we have 14% of customers leaving our company every month, and we have a cost of acquisition that is $70. So if we want to increase our customer base, we need to spend $70 per new customer. Then we have a retention cost, 10,000. This retention cost would be the marketing action that we are going to do when a customer leaves before leaving. So it's the cost of getting to retain the customer that thinks about to leave. Maybe it's a discount, it could be a marketing campaign, whatever it is. And then, okay, the other thing is that we are considering also a success rate for this marketing action. So we are going to target the customers that are likely to leave with a marketing action or a marketing campaign that has a cost, right? That has the cost that it's $10 per customer. And then we have a success rate. No, 60% means that 60% of the customers that are thinking about leaving, that are getting that marketing campaign, would stay in the company. Okay, so with all this data, okay, these assumptions, we ask students to write a mini business plan in a spreadsheet. They put all the assumptions, and then creating a model and downloading the confusion matrix from that model. They can plug in those numbers and make conclusions on the ROI of the model, or how much money or how much more benefit they can bring to the company based in that model. Okay, so this is the data set that is again from BigML. So we have data on past customers. Since it is past data, we know which customers are leaving or not, so we can build a model that predicts the likelihood of a customer to leave the company. And then we are structuring the assignment in different questions, so they have to go question by question and making progress through that assignment. Okay, so probably it makes sense to go to the well, we are asking about the target leakage. If there is a target leakage, to do the sanity check first. Maybe the important thing is to go here. Well, these are all the metrics, questions on the metrics that they will be getting through BigML. And the important thing, as I was saying, is to map all these metrics into a summarized or a simple business plan. And here we can take a look at the solution. So this would be a kind of a standard solution. Now we are asking, okay, we have these different 4 cases when we are evaluating our model. So the true positive, true negative, false positive, false negative, and they are all having different consequences. For example, true positive, it means that we are identifying a customer who is going to churn and is actually churning. Okay, so we would apply this marketing action to that customer. We have a 60% success rate on that marketing action. So we multiply that by the number of true positive. We also have a cost for each action that we are doing on those customers. So overall, the true positive has a benefit or a cost for the company, and we are doing that for all the different cases. So then they can extrapolate this to the 100,000 customers that we have in the company, and they have an overall estimation of the business impact of the model they are building. So basically here, for example, there are two models, model 1 and model 2, and extrapolating this to the 100,000 customers, they have different figures. Okay, so in the model 1, they would get $250,000 as in profit applying that model. In the model 2 is a similar figure, is $257,000. So in this case, this model would be better. Here also, of course, it's not only about those figures. There is also the aspect of interpretability of the model. So as always, we prefer simple models than complex models. So if the profit is similar, we would choose the simplest model, of course. Okay. So the other thing, the last question in this type of assignment is, okay, based on the model metrics, now we have chosen the best model. Based on those evaluation metrics that we have and the assumptions that we were telling students, compute the success rate that we need in the marketing action so that everything is positive in the benefit. So that the break-even point of this success rate in this case is 18%, meaning that if we have the marketing action that has a success rate of 18%, we are break-even. If that marketing action has a success rate of 25%, we are making more money, right? If the success rate of the marketing campaign is less than 18, we are losing money. So this is the type of analysis we like our business students to be making with machine learning. And here you have different success rate, different hypotheses that brings us different profits in the company. And we can do that systematically so that we can do this type of analysis in which, okay, depending on the success rate of this marketing action, we have different profits in the company. Okay, so that would be an input that should be interesting to the marketing department in the company. So now we could go to the marketing department and tell them, okay, if you are able to build a marketing campaign that is 50% success, you get this 195,000 in profit in the company, right? So for me, one of the key points, or what I like to teach our business students, is again how you would make the interpretation that comes from data science into the business world. And this mapping or this business interpretation of the metrics you are getting with your model, this is a task that needs to be done by business people, right? Data scientists or data engineers will not help you or shouldn't be helping you in making those decisions, right? They should focus on the quality of the data, all this ranking data, how to produce good models. But once you have the winning model, so to speak, it comes to it's up to the business people to make the final decision, right? And again, mapping evaluation metrics from data science into the business world. Here we can have, typical analysis, worst case scenario, the break-even, optimistic scenario, and so on. So the idea is that they think about the consequences of the model once the model is created. And also, before finishing, I would like to say that honestly, BigML is a fantastic tool for business school because otherwise it would be almost impossible. Here we can teach our students how to create the models. We can explain them a little bit what is the mathematical structure behind those models without getting into the programming those things by hand, right? If we would imagine those type of courses programming everything, it would be literally impossible, right? And with these tools, we can teach them. We can demystify machine learning. This is also something that I believe it is very important. How I think it's important to demystify machine learning because everyone is talking about machine learning. You open the New York Times and once a week they are talking about machine learning, and it looks from the outside, it looks something like rocket science, something very, very complex. and it could be complex. No, we have deep learning, which is quite complex and difficult to understand. However, there are other models that can be very useful. Again, right? It's not good or bad, it's useful. Models that are useful that are based on very simple statistical approaches, like decision trees, random forest, logistic regression, and so on.